Welcome to lecture for chapter 6.3. We're going to be looking at properties of trig functions. Some of our objectives are to determine the domain and range of the trig functions, determine the period of the trig functions, determine the signs of the trig functions in a given quadrant, find the values of the trig functions using fundamental identities, find the exact values of the trig functions of a given angle, or of an angle given one of the functions and the quadrant, and then use even-odd properties to find exact values of the trig functions. Please make sure that you have already read the chapter and completed your guided notes, so that way you can follow along without confusion. Okay, so what we're going to do is take a look at some of our trig functions and find the exact values of these particular angles. First we'll look at cotangent, then we'll look at cosine, and then we'll look at secant. For our cotangent, we're looking at the exact value of cotangent of 13 pi over 6. Well, what we can do to make this a little bit more manageable is look at what do we know? Well, we know that cotangent of 13 pi over 6 would be the same thing as cotangent of 2 pi plus pi over 6. And the 2 pi isn't going to change our value when we land at that pi over 6. So really, we just need to find out what is the cotangent of pi over 6. And that's where we're stopping on our unit circle. And knowing what we know about our trig functions and our properties and the unit circle itself, we know that cotangent of pi over 6 is rad 3. Next, we're going to look at cosine of 10 pi. And cosine of 10 pi, well, that lands us in the same place. We could think about this as cosine of 2 pi plus 8 pi if we really wanted to. And that lands us in the same place as cosine of 2 pi. And what we know about the cosine at 2 pi is that value is 1. So by thinking about where are we landing, where are we stopping at, and what do we know about that particular position is really our biggest clue to finding these values. Secant of 37 pi over 6. Well, we probably want to be looking at pi over 6, right? Secant, we can break this up as 6 pi plus another pi over 6. That would give us 37 pi over 6. This lands us in the same place as secant of pi over 6. So we really only need to worry about what is the secant at pi over 6. That's 2 radical 3 over 3. If you need to, please review your values at unit circle, at these big places, at 2 pi, at pi over 6, at pi over 3, pi over 4, all our big 3. We need to know our values there. That way we can figure these things out. Okay. Next up, we are going to name the quadrant in which our angle theta lies, and we have 2 clues. Sine of theta is less than 0, and cotangent theta is less than 0. Okay, well, let's think about this. What do we know about the values of these things? If we split our quadrants up, and we're talking about the sine of theta being less than 0, well, that happens down here and down here. That's where our sine is less than 0. Now what about cotangent? Cotangent will be less than 0 here and here in these quadrants. So now we're looking at where do both of these things become true, and we see that they're both true in this quadrant right here, which is quadrant 4. There's a nice table that outlines all of your values if you can't remember them, and I would definitely reference that from your textbook. But if you think about what's happening, remember our sine represents what? It represents our y. So when is our y values negative? Down here. And you can use that kind of logic to continue to find out where are these things, what quadrant are we talking about? Okay, if we are given cosine theta equals negative 1/5 and sine theta equals 2 radical 6 over 5, find the remaining trig functions. So we're looking for tangent, cosecant, secant, and cotangent. So let's write those down. We have cosine, we have sine, we're looking for tangent theta, we're looking for cosecant theta, we're looking for secant theta, and cotangent theta. Okay, so let's just start with tangent. What do we know about tangent? We know that tangent is sine over cosine, which would be 2 radical 6 over 5 over negative 1/5. Using our fraction division knowledge, we would flip it, which leaves us with negative 2 radical 6. Next up, we have cosecant. Cosecant is 1 over sine, which flips what we have for sine. So we have 5 over 2 root 6. Then we don't want a radical in the bottom, so we'll multiply it times radical 6 over radical 6. We'll have 5 radical 6 over 2 times 6, which is 5 radical 6 over 12. Next up, we have secant theta, which is 1 over cosine theta. So we'll flip what we have for cosine, which is a negative 5. Lastly, we'll find cotangent, which is 1 over tangent. Tangent being sine over cosine, so we're putting cosine over sine this time, which gives us negative 1/5 over 2 root 6 over 5. So we'll have negative 1/5 times 5 over 2 root 6, which gives us negative 1 over 2 root 6. We don't want that radical in the bottom, so we'll multiply by radical 6 over radical 6, which gives us negative radical 6 over 12. And that's all that we were missing. We already were given 2, there's 6 trig functions, so we were looking for 4, and we found them. Next, we have find the exact value of each of the trig functions if secant theta equals 2 and tangent theta is greater than 0. So, if secant theta is 2, that means that our secant theta is greater than 0 and our tangent theta is greater than 0. So if secant is greater than 0, that means that's happening here and here. And if our tangent is greater than 0, that's happening here and here. Now, what quadrant do they both happen? Quadrant 1. Now, why is that important? Well, that's going to help us determine that we're going to have a positive x and a positive y. That's going to help us, in turn, find the values of all of our trig functions. So, let's start with what we know. Secant theta is 2. And we can write secant theta as r over x. Remember from the last section? So, if I make my 2 2 over 1, now I know what r is, and I know what x is. So, the last missing piece is finding y, because remember, some point on this unit circle is what we're looking at. So we have 1 and something else, what our y value is. So let's find our y value. Well, we know from the unit circle and also from triangles that x squared plus y squared gives us our r squared. And since we know that r is 2, that tells me x squared plus y squared equals 2 squared. And x was actually 1 squared, right? 1 squared. So we have 1 plus y squared equals 4. So y squared equals 3, so y equals the square root of 3. Now, usually when we take the square root, it's plus or minus, right? But since we're in quadrant 1, our x value and our y value are positive. So it's positive root 3. That's important. If we had negative root 3, it would change our trig values. And now we can get down to business and find all of our trig functions. So first we'll start with sine. Sine is y over r. So our y value is root 3 and our r is 2. Next we have cosine. Cosine is x over r. And our x is 1 and our r is 2. Not so bad, right? Tangent is y over x, which is our y is root 3 and our x is 1, so tangent's root 3. Cosecant, r over y, which is 2 over root 3, and we don't want our radical in the bottom, so we have 2 root 3 over 3. Secant, r over x, r is 2, x is 1, so we have a 2. And cotangent, x over y, 1 over root 3, And we'll do root 3 over 3. Root 3 over 3. And there we go. Sine is root 3 over 2. Cosine, 1/2. Tangent, root 3. Cosecant, 2 root 3 over 3. Secant, 2. Cotangent, root 3 over 3. So it's really awesome that we can figure these values out when we're just given secant and that tangent is greater than 0. We're able to figure all of this out through trigonometry. All right, now we're going to talk about even-odd properties and use them to find the exact values of 3 different trig functions here. So, first off, we'll talk about sine. So, if we have sine of a negative something, I'll just put an x. Then we can use the even-odd properties and say that's the same as negative sine of a positive x. It's really helpful. And then we have a cosine. Well, let's use that property first. So for part A, we're looking at sine of negative 45 degrees gives us negative sine of 45 degrees. And we know what sine of 45 degrees is. That's root 2 over 2. So the negative of it is negative root 2 over 2. Next, if we have cosine of a negative x, we can rewrite that using our properties as cosine of x. So for part B, we have cosine of negative 60 degrees. And we can rewrite that as cosine of 60 degrees. And we know cosine of 60 degrees, that's just 1/2. And then we have the cotangent property. Cotangent of a negative value can be rewritten as negative cotangent of that value. So for part C, cotangent of negative pi over 6 can be rewritten as negative cotangent of pi over 6. And we know pi over 6, cotangent of pi over 6 is square root of 3. So we have a negative square root of 3. The whole list of the odd-even properties is available in your textbook. And those are all the examples for today.